Okay, guys, welcome to another episode of CUDA Education. Today, I wanted to zone in on a specific piece of logic for the metal application. So, as you guys know, we render a triangle, as you can maybe see here. So we render a triangle and we have a triangle that's rotating, right? So yeah, we fully understand that. All right, but what I wanted to what I wanted to focus on was the synchronization logic for actually, reusing the resources and updating the frames and reusing resources, right? So you guys know that the render to frame function is at the heart of how we actually get frames to the screen. Record all of our draw commands. Manage the allocator, which is the the instructions attached to each frame, so that the GPU knows what has to be drawn and all of that stuff, right? So we understand that based on the previous episode. Um, but what I wanted to focus on was the synchronization piece. Okay, so um, we basically have our render frame to view, right? And run through we run through all of the logic. So we begin our command buffer. We associate a bunch of instructions to the frame allocator. The frame allocator is the dedicated memory space that is used to it's like almost like a notepad that is associated with each frame, so that the GPU knows what to do with the frame, what to draw, what instructions it wants to associate with that frame, what it wants done with the frame, basically, right? So we begin command buffer, we end command buffer, we begin render encoder. uh, we have a render encoder and we end render encoder. Okay, but the thing about it is that once we do all of that stuff, we're still in the render frame to view. Once we have done all that stuff, we then submit the command buffer to the GPU, right? So we submit the command buffer to the GPU. The GPU now has all instructions and it knows what it needs to do. It needs to render a frame, and that's what happens as we see the triangle rotate. Okay. But the very last thing is that we have signal when the GPU finishes rendering this frame with a shared event. So this is a synchronization. See, it says signal event. This is a synchronization. Um, synchronization tool that is basically used to tell the world, and specifically the CPU, that hey, these instructions and this specific frame, and the command buffer, the allocator, the memory associated with the instructions for the frame, and the memory associated with the frame itself. We have finished with doing tasks for this frame, and you are clear to basically reset, reuse, clear out everything, right? Notice this instruction is at the very end. So after the instructions have been submitted to the GPU, we then give the GPU, we tell the GPU signal when you're done, and we signal using frame number. Now, from the last episode, we understood that frame number is the holistic number for all frames, that are part of the application. We start at frame, I guess, 0, and we go to a frame, however long your application runs. So if your application runs for, 10 minutes, it's 1,000 frames. I don't know, 5,000 frames. If it runs for a whole day, it's 1,000,000 frames, right? But this is the holistic number for every particular frame, assigned to every particular frame that your application generates, okay? That's frame number. It's a very important thing. So we signal, but we signal associated with that specific frame number. So frame number 123, we have now signaled that, hey, we have done everything with frame number 123. You are clear to reuse the resources associated with this frame, reuse the memory that's associated with this frame, because we have done everything. We have presented to the screen. We have, the GPU has drawn the frame. It has done everything. So now we are clear. We're clear to reuse the resources associated with this frame. Okay, frame number 123. All right. So when we go back now and we're working on the next frame, or not necessarily the next frame, but a future frame, eventually we're going to want to reuse the frame. We're going to want to reuse the resources associated with frame number 123, right? And how do we do that? Well, on the next particular frame, let's say it's, for example, frame number 126, we are going to go through this logic again, right? But now we're working on frame 126. The thing about it is, though, that frame number 126, right? Frame number 126, we're always updating the frame number. So by the 126 call, we are now on frame 126. We have a synchronization event here for the CPU that says, hey, pause, don't move too fast. Only proceed with doing all the stuff, the command allocation, the frame allocator, the begin command buffer recording, and also the render command encoder, all that stuff. Don't do that until the resources associated with frame number 123 is free. So we're going to stop here and we're going to wait until frame number 123 is finished. How do we know that? Because max frames in flight, right? Kmax frames in flight is a variable that was set at the very beginning of this particular part of the script, right? The Metal 4 renderer. Number of frames the renderer works with at the same time. So Kmax in flight is 3. Okay? So if we're on frame number 126, where are we? If we are on frame number 126, 126 minus 3 is frame 123. So let's read out. Wait for the oldest frame in flight to finish rendering before reusing its resources. Self, wait on shared event, for earlier frame number minus Kmax frames in flight. So basically, for earlier frame 123. I'll repeat. Wait for the oldest frame in flight to finish rendering before reusing its resources. Wait for the oldest frame in flight to finish rendering before reusing its resources. Self, wait on shared event, for earlier frame 123. And we know this is 123 because when you do the math here, it's going to be our current frame 126 minus 3, which is 123. So you see there's like a musical chairs handoff of the same set of resources. Okay? So you're not going to go to a new part of the memory, the available memory on your system and start allocating a new batch of memory. You're not going to do that. What you're going to do, which is smart and efficient, is to reuse the same piece of memory that you have already sectioned off. You already sort of have being used by your application, and you're just going to reassign it now to a new frame. And we have clearance to reassign it to the new frame because Well, right, first of all, the GPU signaled here, that we have finished doing all things related to frame 123. And again, the CPU, I guess it's one and the same. It's one and the same, right? The CPU, where is it? The CPU is also waiting for that event, right? So we tell the GPU signal when you're done, and we tell the CPU wait for that signal, okay? So wait for the signal that the GPU says it's done with the earlier frame. Now remember, these frame numbers are always increasing. So we start with, say, frame 123, 124, 125, 126, 127, 128, frame 1,000,000, 1,200,000, 100,000. You know, the frame numbers are always increasing, right? So the resources for the frame that you're currently working with, we are reusing the resources that was used for 3 frames earlier, okay? And it's a very important thing. Synchronization is extremely important in GPU programming because, as you guys know, GPUs are running really fast, okay? And it's also able to do parallel processing. So, you need to make sure that, it's not just a matter of how fast you could sprint the 100-meter. You have to make sure that you're not colliding with, you're not corrupting, or you're not using old information in when you're doing your sprint. You have to make sure that the information that you're using, these things aren't completely independent individual things. They are sort of related to each other, right? So you have to have synchronization to make sure, okay, can I proceed with the next step, right? It's almost like you're at the gas station and you're filling up your car with gas, and you decide in the middle of filling up your car with gas, you're gonna drive off, right? With the nozzle still in your gas tank shooting out fuel. It doesn't make sense. You have to say, okay, have we finished fueling the vehicle? Yes, we have finished fueling the vehicle. Okay, remove nozzle from your fuel tank. Okay, remove nozzle from fuel tank. Okay, put on the fuel cap, right? Okay, we put on the fuel cap. Okay, close the fuel door. Okay, fuel door closed. Okay, start engine. Okay, start engine. Then we could go. You don't, in the middle of you of pumping gas, you're gonna start your engine and drive off, right? It doesn't make sense. Things have to line up in order for the process to be done correctly. So this particular piece is our first touch of synchronization in Metal, okay? And it's a very important piece of the puzzle. So that's what I wanted to basically talk about today. This is CUDA Education. Make sure to like, subscribe, tell your friends, all of that good stuff. I've included a bunch of links in the description below, so check those links out. If you have an Apple machine, learn Metal in 2026. Don't let the whole year go by and you haven't learned Metal or started your journey. Thank you guys for watching. Have a great day.